Good morning, all of you. My name is Saikiran. I am your chemistry lecturer. In our last class, we discussed J.J. Thomson model, Rutherford model of atom. Today, we will discuss important basic terminologies related to atoms. The general representation of atom is here X is an atom, Z is atomic number, and A is mass number. In order to calculate number of electrons, protons, neutrons, we must learn atomic number and mass number. Now we start with atomic number. It indicated with Z. The number of protons present in an atom of an element is called atomic number. For example, helium atomic number is 2. Beryllium atomic number is 4. Fluorine atomic number is 9. Let's see the calculation of protons. In case of neutral atom or cation or anion, number of protons is always equals to the atomic number. For example, helium atomic number 2. In this, number of protons is equals to atomic number that equals to 2. This is the neutral atom. There is no charge present on it. For cation, number of protons is equals to atomic number that equals to 4. For anion, number of protons is equals to atomic number that equals to 9. Let's see the calculation of electrons. In case of neutral atom, number of electrons is equals to the atomic number that equals to 2. For cation, number of electrons is equals to atomic number minus number of electrons lost. This plus 2 indicates this beryllium ion lost 2 electrons. That is atomic number 4 minus lost electrons 2. That equals to 2 electrons. Now this beryllium cation contains 2 electrons. For anion, number of electrons is equals to atomic number plus number of electrons gained. This minus 1 indicates this fluorine gained 1 electron. That is atomic number 9 plus 1 that equals to 10 electrons. Now this fluorine anion contains 10 electrons. Now come to the mass number. It is represented with A. It is nothing but the mass of one atom of an element is called mass number. It is equals to the sum of neutrons plus protons. That is mass number equals to sum of protons plus neutrons. From this, we can calculate number of neutrons. That is neutrons equals to mass number minus protons. That equals to mass number minus number of protons. We know that always equals to the atomic number. That is Z. For example, nitrogen atomic number 7, mass number 14. In this, number of neutrons is equals to mass number minus atomic number that equals to 7. Similarly, beryllium mass number 4, atomic number 4, mass number 9. In this, number of neutrons is equals to 9 minus 4 that equals to 5. Now come to the mass number of nitrogen. Mass of nitrogen that equals to 14 AMU. This AMU stands for atomic mass unit. The mass number which tells us how an atom of an element heavier than the 1 AMU. That is equals to 14 into 1 AMU. Now the question is, what is this atomic mass unit? Let's see. 1 AMU is equals to 1 D. D stands for Dalton. That is equals to 1 U. U stands for unified mass. That equals to 1/12 of carbon 12 atom. That equals to 1.66 into 10 to the power of minus 24 grams. That equals to 1 by Avogadro number. Avogadro number is nothing but 6.022 into 10 to the power of 23. This is the values of 1 AMU. This carbon 12 atom, the mass of 1/12th carbon 12 atom is the reference. With this reference, we can calculate the other atoms and elements masses. For example, mass of nitrogen, that equals to 14 AMU. That is equals to 14 into 1 AMU. That equals to 14 into 1/12th of carbon 12 atom. Which means the mass of nitrogen is 14 times heavier than 1/12th of carbon 12 atom. Similarly, mass of oxygen, that equals to 16 AMU. That equals to 16 into 1 AMU. That equals to 16 into 1/12th of carbon 12 atom. This means the mass of oxygen is 16 times heavier than 1/12th of carbon 12 atom. Now the question is how this value is obtained. Let's see. The mass of carbon 12 atom is calculated from mass spectroscopy. That is 1.99 into 10 to the power of minus 23 grams. We know that 1 AMU is equals to 1/12th of carbon 12 atom. That is 1.99 into 10 to the power of minus 23 grams. That equals to 1.66 into 10 to the power of minus 24 grams. Now come to the one more important terminology, that is isotopes. The atoms are same elements having same atomic number and different mass number. We call it as isotopes. For example, hydrogen have 3 isotopes: protium, deuterium, tritium. And carbon have 3 isotopes: carbon 12, carbon 13, carbon 14. These are the isotopic forms of these elements. The isotope shows same chemical properties but different physical and radioactive properties because the number of electrons and protons is same but the number of neutrons is different. And the fractional atomic masses of elements is due to the presence of isotopes. That is, for example, mass of chlorine is equals to 35.5. These fractional values comes out because of this chlorine exists in the form of isotopes. And the E/M values of these isotopes is not equal because the masses are different. Next one is average atomic mass. Whenever an element is exist in the form of isotopes, we always calculate average atomic mass. In order to calculate average atomic mass, we need percentage abundance of these isotopes. Percentage abundance is nothing, the percentage of this isotope available in the nature. Let's see case 1. An element having 2 isotopes. For example, X is an element. It is present in 2 isotopic forms. The percentage abundance of this form is A%. The percentage abundance of this form is B%. The sum of all these percentage abundances, all the isotopes of an element is always equals to the 100. That is A plus B equals to the 100. Now come to the calculation of average atomic mass. That equals to M1A plus M2B divided by A plus B. Let's see one example. Chlorine exists in 2 isotopic forms. That is chlorine 35, 37. Average atomic mass of chlorine is equals to, this form exists in percentage abundance is 75% and this is 25%. That equals to 35 into 75 plus 37 into 25 divided by 100. That comes out to be 3550 divided by 100. That equals to 35.5. The average atomic mass of chlorine is equals to 35.5. Now come to the case 2. An element exists in the form of 3 isotopes. Percentage abundance is A, B, C. Now the formula is M1A plus M2B plus M3C by A plus B plus C. Let's see one example. Magnesium exists in 3 isotopic forms. That is Mg24, Mg25, Mg26. The average atomic mass of this magnesium is equals to, these are percentage abundances is 79%, 11%, 10%. Now 24 into 79 plus 25 into 11 plus 26 into 10 divided by 100. This value comes out to be 24.31 AMU. This is the average atomic mass of magnesium. Now come to the next terminology. Isobars. The atoms of different elements having different atomic number and same mass number. We call it as isobars. For example, carbon and nitrogen. Different atomic numbers and same mass number. And argon and calcium. They both have different atomic numbers and same mass number. These are called isobars. Isobars shows same physical properties and different chemical properties due to different number of electrons present. Now come to the isotones. Isotones. The atoms of different elements having different atomic number and different mass number and having same number of neutrons. We call it as isotones. For example, carbon and oxygen and sodium and magnesium. We already know that how to calculate number of neutrons. That is equals to mass number minus atomic number. Number of neutrons is equals to, in carbon, 14 minus 6, that equals to 8. In case of oxygen, 16 minus 8, that equals to 8. Both the cases, number of neutrons is same. In this case, number of neutrons in sodium, 23, mass number minus 11, that equals to 12. In case of magnesium, 24 minus 12, that is equals to 12. Both the cases, number of neutrons is same. These are called isotones. Isotones shows different physical and chemical properties because number of electrons and protons are different. Now come to the isodiaphers. The atoms of different elements having same isotopic number. We call it as isodiaphers. The isotopic number is nothing but the mass number minus 2 times of atomic number. And they possess same difference in neutrons and protons. For example, fluorine and sodium. Number of neutrons in fluorine is equals to 19 minus 9, that equals to 10. Number of neutrons in sodium is equals to 23 minus 11, that equals to 12. The difference of neutrons and protons is equals to, in case of fluorine, 10 minus number of protons is 9, that equals to 1. In case of sodium, neutrons is 12 minus number of protons is equals to 11, that equals to 1. Same. So these are called isodiaphers. Let's compare isotopic number also. For isotopic number, for fluorine, mass number is 19 minus 2 times of atomic number, that is 18, that equals to 1. In case of sodium, mass number is 23 minus 2 times of atomic number, that equals to 22. This isotopic number is also same. These are called isodiaphers. Next, isosters. The molecules contain same atomicity and same number of electrons. We call it as isosters. For example, CO2 and N2O. Now the question is, what is atomicity? Atomicity is nothing but the number of atoms present in a molecule. Atomicity. In CO2, 1 carbon and 2 oxygens are present. 1 atom, 2 atoms, total 3 atoms are present. In case of N2O, 2 nitrogen atoms, 1 oxygen atom present, 3 atoms. Atomicity is same. Now come to the calculation of electrons. Carbon have 6 electrons. Oxygen have 8 electrons. 2 oxygens is there. 2 into 8, 16 electrons. Sum of these two, we get 22 electrons. In case of N2O, nitrogen have 7 electrons. 2 nitrogens is there. 2 into 7, 14 electrons. In case of oxygen, 8 electrons is there. Sum of these two, 22 electrons. The number of electrons is also same. So we call it as isosters. Isoelectronic species. This is very important terminology. Majority times question asked from this concept. An atom or ion which having same number of electrons, we call it isoelectronic species. For example, nitrogen minus 3, oxygen minus 2, fluorine minus, neon, sodium plus 1, magnesium plus 2, aluminum plus 3. These are cations. These are anions. This is the neutral atom. Now, come to the calculation of electrons for all these atoms. Number of electrons. In case of anion, atomic number for nitrogen 7 plus number of electrons gained, total 10 electrons. In case of oxygen, atomic number is equals to 8 plus number of electrons gained 2. The sum of these two, 10 electrons. In case of fluorine, atomic number is equals to 9. Electrons gained 1. Total number of electrons is 10. In case of neon, this is neutral atom. This number of electrons is equals to the atomic number, that equals to 10. In case of sodium, atomic number is equals to 11 minus number of electrons lost, that is 1, that equals to 10 electrons. In case of magnesium, atomic number is 12. Number of electrons lost 2, that equals to 10 electrons. In case of aluminum, number of electrons is equals to atomic number 13 minus number of electrons lost 3. So this comes out to be 10 electrons. In all these atoms or ions contains same number of electrons. So we call it as isoelectronic species. That's it today class. In our next class, we will discuss development towards Bohr's model, that is dual nature of electromagnetic radiation and atomic spectra.